This conference will now be recorded.
Okay. So good morning and good evening, everyone. Welcome to the DevOps and Kubernetes training. Am I audible?
Yes, you are.
Yeah.
Can anyone tell me? Am I audible?
Yeah, it's perfect.
Yes, you are.
Yes, sir. Yes.
Am I audible? No.
Yeah, it's perfect.
Okay.
Please go ahead.
Yeah. Thank you. Thank you, Aswant. Okay, I'm recording this session as well. I can share you after the demo. So I request all of you to unmute yourself, and we will have a separate time for the doubts. So once I start explaining the topics, so we can have some time for the doubts and the questions. Okay. So if you get really a doubt, then you can unmute yourself and you can ask. But preferably is we can hold the questions uh, until end of the presentation. Okay. So the training is about Docker and Kubernetes. So before Kubernetes, why we need Kubernetes? So we should understand the knowledge. We should understand the concept of containers. So in containers, we mostly hear Docker containers, and there are other containers also like Rocket and Linux containers. But Docker is the famous out of all, just like Google Chrome is most famous browser other than all other browsers. Okay, so before understanding Kubernetes, so we need to understand a few things. What is containers, why containers, and then we can go for Docker, and then we can discuss what are the replacements for the Docker and what are the other options available for Docker as well. Okay, so let's forget what is Docker, all these things. We will discuss about the current architecture, or at least 5-6 years back architecture, how the normal servers are working. If you have some business and you want to host an application and you want to publish a website to the others, so you need basically a server to host your website, and this was a earlier architecture. So I know most of you all knows about this concept, but so I need to I will quickly take you through this old concepts, and then we can discuss more on Dockers. But this introduction is very much needed for now. So this was the earlier architectures. We had hardware, I mean like CPU and storage, all those things. And then on top of that, we install operating system, preferably Unix and Linux and Windows servers. And on top of that, we install application server and we host the application, and then users can start accessing those applications. So for the next session, for the upcoming, like for today's topic, you just think yourself, you are hosting a website for your small business and then publishing it to the internet. So this was the previous architecture, and suddenly maybe your business is becoming more popular and you are getting a lot of requests from the internet and you are getting a lot of traffic to your website. So then you have to definitely increase the capacity of your servers. So then you definitely need more servers. Suppose one server goes down, at least other server will serve the traffic. Okay, but installing more and more servers is not an easy task. So you need to manage the power, you need to manage the space, networking, and then patching. So you need to spend a lot of amount. At one point of time, you may feel your revenue is very less than the your software management. Okay, so till this point, I think all of you aware of this architecture. Just a physical servers management was not so easy. It was not so easy. Okay, and then so these are the disadvantages. So you need to pay for the server, you need to buy the server, that will be at least 2 to 3 lakhs. You need to pay for the many other things, and you need more resources to maintain, to set up the server, to install the OS, and to configure the server. And so whenever you are going for this upgrade, you need to maintain some business downtime. So earlier we were seeing some maintenance pages on the banking servers. So there is a schedule maintain downtime. The server is not accessible, or system is not accessible until 12 hours, until tomorrow morning 6 a.m. So like that we were seeing some messages. That was because of upgrading the softwares and adding the more servers, all those things. Less scalability. So you cannot scale very rapidly, so you want to take some time. You need minimum 1 month time to buy the server, to install operating system, applications, all those things. And no resource optimization. You cannot effectively use your resources, and you need more space, power, and bandwidth also you have to provide for each and every server. So all these are the disadvantages. So considering these disadvantages, the software industry came up with a solution called virtualization. So this was the game changer at that time. So you are having the hardware, and on top of hardware, you will install, you have the host operating system, just like the normal. And on top of host operating system, you install VMware. So using this software, VMware, it means like hypervisor technology, and you can have multiple logical servers in a single host. So so this gives you a lot of advantages. You no need to buy more and more servers. Within the single server, you can partition it, and you can run multiple logical servers on top of single host. And you can have an advantages of having different versions of OS. For example, you have developed an application, you need to test that application, how it is behaving in different Windows 8, Windows 10, and then Windows 7 and Ubuntu desktop, all these things. So to test that, you can have different operating systems here, and you can deploy this application, test in this server, and you can have different OS flavor here, and you can test this application. So these are the multiple advantages of this virtualization software. And it's cheap because you no need to buy more and more physical servers, and it is very easy to manage because it's a single host. Just you need to understand how the VMware software works, and it is scalable also, because you need to run multiple servers, and you host your application, and you can create load balancer between these two. So then your application will serve good amount of traffic. And as I said, you can install multiple compatible OS flavors, and it will be definitely highly available. So this technology changed the software infrastructure world. Every company installed hypervisors, and they came out of the physical servers, and then started working with the VMs. Okay. So this is, I want you to compare this technology, physical server and the virtual machines, with like independent house and the apartment. And in apartment, suppose if you have the space, compare this with physical server. You only can live in this home, so no one else can come and live with you, right? So uh, and then in apartment, using the same space, you can build a multi-story apartment where you can accommodate a lot of persons, just like this. Okay, but the space is same, but here more people are living, and here only one family is living comfortably. Here if you do something like shared resources like swimming pool, you can have gym, all those facilities you can provide, and you can accommodate more number of families comfortably. So yeah, just if you have more money, you go with independent house. If you have less money and you want more facilities, then you go with apartment. So obviously when you are running a business, for example, now you can start thinking of your business. So for the entire Docker and Kubernetes course, I will tell you, you assume you are doing a business like constructing homes, and selling it, or constructing homes and giving it for rent. Suppose you started constructing this house, now you get rent from the only one family, and you feel this is not giving good profits to you, and within the same space you created a multi-store building, and then you started getting a lot of money. So just relate this example with the physical server and VMs. Okay, but if you want to live your own self, you may prefer independent house because you have a lot of money and your requirement is independent. Okay, any doubts till now?
No, Shiba, it's fine.
Oh,
Oh, sure, you can
okay,
continue.
right. Sorry, I did not see your messages. Hello guys. Am I audible? Okay. So I thought you cannot hear me. I can see some messages. Some people are not able to hear me.
Shiba, right now your voice, I'm feeling like you are on speaker and you are speaking from a distance like that.
Okay. So earlier, was it good?
Shiva,
Earlier
your
was
voice is echo.
it was better, lot better.
Okay. Yeah. Then I'll go with it. Okay. So can someone? Is anybody speaking?
No.
Hello.
Yes, we are able to hear you. Yeah.
Oh, I think I cannot hear when I'm on Bluetooth, or nobody is speaking.
Shiva, are you able to hear us?
Yeah, able to hear.
Yeah, we are able to hear you, Shiva.
Okay, I think I'm audible, so I can continue, I hope.
Yeah, of course you are audible. We can hear you.
Okay, so if you get any doubts, you can send the messages in chat also in between. Okay, yeah, so I can continue now. So this is what the brief understanding about physical servers versus VMs. Okay, so companies can use that hybrid kind of architecture. So these are the characteristics you should have in your mind while comparing this physical and virtual machines. So scalability is really bad in physical and it's very good in VM because you can easily provision the new servers, and then resource allocation is good. Why I said good here is you have a lot of resources. You have CPU, you have hard disk, and whenever you are running for one application, you always choose uh, maximum it may use 30 to 40% only. So the resource allocation is good, and in VM up to a limit it is good. For example, you provision a VM for 4 GB RAM maybe, and then 80 GB hard disk, and suddenly if your application started consuming more memory, then you cannot allocate the resources. So that's why I said up to a certain limit this is good. And security is also really good in your physical server because you have hosted a single application on single server, and VM also the security is very good. Resource optimization is bad. Why? Because you cannot allocate your resources to other applications. And in resource optimization characteristic, VM is very good because you are sharing your resources to many logical servers. And then high availability is bad in physical machine, and it's really good in virtual machine. Cost optimization, it's bad because you need more money to buy new servers, and it is good here. Reliability is bad because of not high availability inside your physical machine, and it is bad as well in VM because suppose you are running one application in your VM, suddenly there may be a corrupt in your OS or in your application or patches, so your application will not respond. So that's some up to some level it is bad, not completely bad. And provisioning, you cannot provision the new infrastructure in physical machine so easily, and VM it is very good. Performance in physical machine performance is good, but in VM performance is somewhat bad. Why? Because it's basically, suppose, so what is the VM architecture? So you have your hardware, and top of that you have your OS, and on top of that you have your VMware, and on top of VMware you have again one guest OS, and on top of that you have an app. So if your request or HTTP call something, when you hit, for example, facebook.com, first it will come to this hardware, and it will go to the OS, and then OS will communicate with the VMware, and then it will communicate with the guest OS, and then the communication will go for application. So that's why number of calls and layers are very high. The performance is not so good in VM. Okay. So that's why the performance is not so good. Oh, shit. Oh, just 1 second. Oh, any doubts still now? Okay, things are right. Okay, so yeah, HA, high availability. Okay, so this is about the comparison between physical machine and VM. You need to tell these points if anybody asks you, or if anyone of you face this question. Okay, so this is not gone. I think it's not erased. Okay. So are VMs best? Now we can, you can think yourself, every company is using VMs from last 5-6 years. So now if you want to maybe improve the VMs also, you need to think about these points. So if, as I already said, if an application in VM1 wants more resources, so it's not possible suddenly. And if application VM in VM2 is using very less resources, maybe 10% of resources, can you share these resources to another VM? That is also not possible. And how about performance? So as I said, performance is very less in VMs. And so when you want to spin up a new VM, so it will take some time, definitely, maybe 5 to 10 minutes or 10 to 15 minutes. So so all these things you can think these areas are for the improvement, and we can discuss the next thing, how can we address these issues. So now let's back to our example. You have your business, right, constructing homes, independent houses, and then you started thinking that is not giving more money, and you went for apartments. And inside apartments also, you got a different idea. So why I give a single flat for maybe 20,000 rent for a single family? So I can partition it 3 rooms. Maybe you can give for single room 10,000, and you will get 30,000, 10,000 rupees more amount. And so now this is the concept, right? In PGs and some applications like Nestaway startups. So they came up with a different idea. So they will take flat. Maybe if you have a flat, they will take that flat for rent from you, and they will partition it, and they will start giving rent individual rooms. So that gives them some profit. So that's the business. So same here, same application you can relate to the VMs. Within VM also, you can partition it, and you can go for containers. So that container architecture we will discuss in deep. So this is the real life example you can think of it. So containers are very easy. So let's draw the container architecture. Okay. So maybe this is your server, and on top of that, so you have the host OS, and now you can run containers. Okay. So this is your hardware. This is your OS, and here you can directly run container that have OS and some application runtime, and then libraries. Okay, so now within this can be a VM also. This no need to be a physical server. This can be a VM also. So within VM, so whatever we discussed in this case, so in this VM also, you can plan for better resource utilization. Okay. So now this is your hardware, this is your OS, and on top of it, you run this is called as container. So this we call it as image actually, and then this image contains a bare minimum OS and a minimum runtime and the libraries. For example, so if I buy a laptop, maybe in my BTech, so I was not using it for the multi-purpose. Maybe I was using it only for watching movies and listening to songs only. So here, if you are running a container, so you use it for a special purpose, just host a website. You don't do any other things. So that's why we go with the bare minimum OS. So if in OS like Windows or Windows, you have lot of process running in background. So we don't know what are those things, and we don't require all those things which consumes lot of memory, lot of hard disk in a server world. So if you need bare minimum OS, that is enough just to run your application, post your application to send, to get the request and to send the response. So that's why the memory will be very less, maybe up to 200 to maximum 200 MB, or even very less than that. You can make it up to 100 MB only in your real-time applications, real life applications, and that gives you a very good performance. Okay, so this is what the containers, it's not a very new technology, it's just understanding the difference only. Other than that, it will have the OS, it will have all the softwares installed, and it will have the network connections, everything. Okay, it's not a new technology. At least don't think it's a very hard and new technology, because the new technologies are making our life is very easier. It's just you need to understand what it is and what are the problems it is solving. So when you are learning a new technology, so before that you need to understand what problem it is solving and what are those problems, how can we address those problems in this technology. So that's it. And earlier it was very difficult without VMs and without Dockers, the resources they were doing night outs, they were spending a lot of sleepless nights to make the applications up and running. So now it's not at all like this. You can do anytime deployments. That's because of the development in the technologies only. Okay, so the Docker or containers, it is very simple to provision. It may take, so if the VM takes 15 to 20 minutes, the Docker container may take only less than a minute to start. Okay, so boot up time is very, very less. And it will share the OS kernel, so the performance is very high. And you can install these containers inside your desktop, in VMs, in physical servers or VMs, and in public and private clouds, and even you can install the containers in your mobile also. You just need one server or one computer. So in my opinion, server or computer, mobile, it's no difference. A computer or server is nothing but a IP enabled device with some OS, RAM, and then storage and processor. That's it. So you can install this containers in your mobile also. Okay, and each container contains a standalone image, as I said earlier. So this is the image. The image consists of this thing, a base image and some runtimes and some libraries. Okay, and it will have some tools and libraries. And so now if you just think VMs are very fat, containers are very thin. So VM have a lot of, it will have the complete OS, it will have the complete softwares installed, but the containers will have only the necessary packages or necessary softwares installed. Other than that, containers will not have much thing. So you can say VMs are fat, containers are thin. Okay, so this is what about the containers. And now if you see the differences between VMs and containers, scalability is bad in VM, and then in containers, or we are going to discuss about Docker. That's why I have written Docker here. So all the characteristics are good except security, because if I get an access, if I get an root level access to one container, the hackers can easily hack the entire containers running inside that host machine. Okay, so but we can tune this, we can have some restrictions. No container will run as root user. So there are some best practices we follow in real time to make the security good. Okay, so that's not a hurdle that we can address. So just we need some tuning. Other than that, all characteristics are good in containers. That's why now all the companies are moving towards containerization. So now earlier we were writing Java based applications in JSP. Those are installed in physical servers. So later we moved to RESTful services. Now we move to microservices. So microservices, we are going to deploy them inside the containers. Okay, so
Excuse me,
it's
Shiva,
the
sorry
most
to interrupt.
trending technology now in the market: containerization, Docker, Kubernetes, OpenShift, all those things. So these are the advantages. So you might definitely get these questions in interview. So what are the advantages of containers or VMs or physical servers? You can mention all these points.
Shiva, sorry to interrupt. Am I audible?
Okay, so now you decided to go with containers. So now here again one more problem will come. So you are using containers, maybe you containerized all your softwares in your company. Now how to manage all those containers? Yeah, I think I'm not getting anyone voice. Can you add?
Shiva, Anusha here. Am I audible?
Alisha, we are able to hear you. But
No, I'm not audible. Should I use? So for now, I think I can just.
yeah, we are able to hear you.
Yeah. Can you speak? Who has doubt? Can you speak now? Just adjust for now. Maybe my voice is getting echo to you. So my Bluetooth may be some problem. I cannot hear any one of your voice. Can you speak? Okay. So till now, any doubts?
Yeah, Shiva, I have a doubt.
Yeah.
Can you please go to previous slide?
Oh shit, sorry. This one?
Yeah. See here, you are saying
Yeah.
the security not security is bad in Dockers, right? And
Yeah.
nowadays all the companies are preferring a Docker compared to VM. But the security is the key point. We need to take care. If I'm not wrong. So can you please explain how we are ensuring security in Docker?
Yes.
We are
So
importing Dockers in our companies, so we need to make sure the security also imposed, right? So in how we are achieving this?
yes, definitely. So the point here is maybe you are running 100 containers within a single host. One container may be compromised of running with root level access. So ultimately, the Docker container is sharing the host hard disk, right, to store and to communicate all those things. So if one container by mistake is running with the root level access, that container, using that container, you can access the file system of the host, which is sharing to the multiple other containers as well. Okay, so for example, in your flat room, if your friend may come up with some unauthorized access, so he can access all the shareable resources, right? So we need to make ensure while deploying the containers within the host, you should not run with root user access. So you should stop maybe your pipelines, your delivery process. You should ensure that your containers are not running with root level access. And you can have some vulnerability softwares that will scan your images and it will tell before going to the production. If you have any root level access gaining, then those containers will give warnings, and by default you can make your CI/CD to fail at that point of time.
Okay, got it, Shiva. Go ahead.
Yeah.
Thank you.
So now you adopted the containerization technology and you have thousands of containers running, and how will you manage? So same problem when you are running physical servers. Maybe you are running a e-commerce website, you have thousands of servers earlier. So you are not using, you're not logging into the single software and running the patches. So you are using some configuration management tools. Maybe you are using Chef, Rundex, SaltStack, and Ansible. So those machines will do the management of all your physical VMs or virtual VMs. So now the same problem comes up with the containers also. You have thousands of containers. Who will manage those containers? So now the solution is Kubernetes. Yeah. Is my voice not clear?
Yeah, it's clear, Shiva.
Okay, thank you. So just bear with me for today. So tomorrow I'll come up with new arrangement. Yeah, so now Kubernetes is the solution to address. So what is Kubernetes? It's orchestration tool. Just you can compare with whenever you are seeing some orchestra, there will be a person like him giving the instructions to all these guys. So otherwise you cannot run the orchestra will not perform good, right? So same like you have thousands of containers running in your company, you need some orchestrator software to manage all those containers. Otherwise it's very difficult to manage each and every container separately. So why Kubernetes is the most preferred one? You have other options like Miso OS and Docker Swarm, a native orchestration tool from the Docker software itself. So why Kubernetes most preferred, and almost every company is using Kubernetes. Even the OpenShift, EKS, AKS, GKS, all these things backbone is Kubernetes only. So it's open source and it's from Google. So before the world knows the containerization technology, or means like before the world knows the Docker, all these things Google was using in its company containers, Google containers, and they were using this Kubernetes with a different name in Google company. So maybe from the 2002 or 2003, Google started using containers and this Kubernetes project they have in their company. So after some point of time, they contributed this project to the open source community. So it's a very stable one and it has a lot of features, scalability. So initially you can run your application with scale out manner, maybe a single instance. Once your traffic is getting increased, then it will scale in automatically. So it's basically you have auto scaling feature in Kubernetes, and it's a within a point of within seconds you can configure new pods and start serving the traffic, and it's a very cool visibility. So your Kubernetes is most used by most of the market, and you have more community support, and you can have your version control of your pods. So I'll tell you what is pod. Just you think it's pod as a container. Maybe you're running one container now and you found some issue with your application, so you created another version of your container, and you can spin up that container very easily, and if something goes wrong you can roll back it also very easily. So this you will see this particular feature when we start practicing, and it supports zero downtime deployments like blue green canary deployment, rolling out deployments. There are 6 deployment strategies, and it supports the zero downtime deployments. Now no need to set up a maintenance window in your business, and it's a purely you're writing the code and publishing it to the Kubernetes. It's basically called as GitOps. So everything you may know about the infrastructure as code, right? So even you no need to go and do the changes physically or through any web console to your servers. You can just write a script and upload to the Git. From that point of time, it will trigger CI/CD pipelines. They will take care of spinning up your infrastructure or your application from dev to SIT, UAT, and prod. So now nobody is preferring to go and log into the console and clicking some options. So everything is configuration is also a code. So that's called GitOps. It's a very popular term, and like it's just like one good feature in DevOps. So that's about Kubernetes. So this is why we prefer to learn Kubernetes than like other Terraform or Miso or something like that. So the Kubernetes architecture is like this. You will have a master node and you have some host servers. So in this node 1, node 2, node 3, in all these nodes you have your Docker software installed and you are running these containers, and you can interact those. You cannot interact with these containers directly. So whatever you want to do something, deployments or increasing all those things, you communicate to the master. So master take care of all these things. For example, you want your application to run in 3 different nodes. So you just select, I have my application, run this application in 3 different nodes. So you publish that configuration to the master. The master will take care of pushing that application to these 3 nodes. If node 1 goes down, then your application is still accessible. Okay, so you have your Kubernetes master node, and that master node is connected to the server nodes or hosts through agents, and those agents have access to the images registry, and then you can start publishing images to the images registry and then running the configuration from the command line or some Kubernetes UI and publishing that to the master. So master will spin up all your configurations with this. So at this point of time, we cannot go very deep into the Kubernetes architecture. So before Kubernetes architecture, you should definitely have hands-on on Docker containers, imaging, all those concepts. So that's why I'm telling you very high level architecture of Kubernetes. Just think there will be a lot of host servers. On top of every host server, you have Docker software installed, and you are running containers in many hosts, and those containers are managed by Kubernetes master. So that is enough for now. And once we complete Docker, we will go to the low level architecture of Kubernetes, what happens in every node and how the master really manages them. Okay. So as part of this course, first we will discuss about Docker. We will install Docker software, and we will discuss what are the Docker commands: Docker run, Docker ps, Docker images, Docker start, Docker inspect. So there are some very few commands, maximum 10 commands. And then we will discuss how to create images, how to run images as containers, and what is Docker Hub, I mean like Docker registry, and how to write a Docker file, how to build a Docker file, how to tag it. So we will deploy one application in physical server, and we will see how painful it is, and then we can go for Docker. So at that point of time, we can see how easy it is to deploy a real-time application in host versus Docker containers. And then we will discuss some best practices to write Docker files, and we have a concept of multi-stage Docker builds. So these are the must and should concepts you should understand so before going for container orchestration service. Okay, so just writing a Docker file is not enough, because maybe so if two developers are there, one developer writes a Docker container which will come up around 500 MB. So maybe other developer too can write the same container which will come up to 300 MB. So we should remove some unnecessary packages, unnecessary installations. So same like in your personal laptop, when your laptop is running really so slow, you will uninstall some softwares, you will remove some space, then it start performing better. So similar kind of approach you should think of while writing the Docker files and Docker images containers. Okay, so you need very bare minimum requirements to run your application into the containers. And then in Kubernetes, we will discuss how to write YAML files and Kubernetes architecture. K8 means just Kubernetes, has 8 letters. And then how you will set up Kubernetes architecture in physical servers, I mean like on-premise servers. How will you automate it? Setting up the Kubernetes architecture using Ansible playbooks. And then we will discuss the disadvantages of maintaining Kubernetes on-premise, and then we can go for any cloud service. If you have public cloud in your company, you can install the Kubernetes in public cloud. And if you have private cloud, you can install Kubernetes in private cloud also. And if you decide to go with OpenShift, then the vendor will come and they will install the OpenShift software. OpenShift is nothing but underlying Kubernetes. On top of Kubernetes, Red Hat have written some wrappers to give more features, an enterprise version of Kubernetes, I can say. So you have different multiple options. You can maintain it on premise, or you can go with cloud. So good option is to go with cloud, or at least vendor support. And after that, you can discuss something about Kubernetes objects like pod, service, how can you attach volumes, persistent volumes, namespaces, deployment, daemon set, stateful set, replica set. So these are the actual core Kubernetes of these objects, right? You should have thorough understanding of all these objects. And then we can discuss about the deployment types, and we can use blue-green deployment. It's like zero downtime deployment, and we can have discussion about Helm charts. Helm charts is nothing but a package management for Kubernetes, just like M command. So we have Helm command to install the Kubernetes applications very easily. So you can just install Jenkins software within a minute using Helm charts. So that's the real power of Helm. It's very useful concept in real-time world. Just simplifying your Kubernetes deployments, and we can deploy one real-time project into the Kubernetes environment, and we can use Jenkins also to automate the deployment process CI/CD, and we have a continuous delivery tool called Harness. And also we can use it for the deployment of your infrastructure as a code and your application. And we can log all the requests coming to the Kubernetes with ELK application log, system level logs, and all the things. We can have login feature, and you need to have the monitoring software also. We can try with Prometheus to monitor your resources. So all these things are not the new things. These are the common problems for any technology. So what is your process of release, whether it is automated or manual? So if it is manual, definitely there will be a mistakes. So definitely we should use CI/CD. And do you have monitoring software? Even how powerful it is your release process, you should always monitor your resources. And you should have logging features also. So and all these are like common problems, and these are common solutions, not only with Docker and Kubernetes, with any other technology. Okay, so I will tell you how we are going to use this. So these are the things. So first we will write everything into the GitLab repositories, and I can share with you all those repositories like Ansible setup, how, and Terraform also, how you will set up Kubernetes automatically with Terraform and with Ansible. And you have the commands we can discuss, add command, CMD. So these are from previous batch. Okay, so we can discuss, we will write at that time. I don't show you from these repositories. I will create the repository in the class. I will write all these commands. I will make you understand. Then I will publish to the GitLab. You can start using it again. So this is a sample of a Docker file, how we are going to write all these files, and how can you learn these commands. So by practicing everything. Okay, and I'll share you some Docker commands we are going to use. So like this. So all these things I'll write while in the class, and we'll discuss some Helm charts, how we are going to automate the deployments with Kubernetes packages with Helm charts. Okay, so this is our project student application, and we have images also, some common images we are going to use throughout the course. Okay, so we note down everything into the scripts, and we will share those scripts through the, as I said, GitOps. Whatever we do the changes into our applications, it's through the script only. Okay, so we don't change anything in the console or command line. Everything is, we write scripts, and using those scripts we change the environment. So now you can see the very important of Kubernetes objects, how we are going to write your pods. We have a lot of features in the pods, how you are going to use. So for this you need to have the AML understanding. We will discuss about the AML also, how you have to write. Okay, so these are pods. So inside pods we discuss a lot of options: config, map, secrets, volume, security context, and then jobs, how you spin up ingress controllers, services, load balancers, everything we discuss. And these are very important: replica sets, and then stateful sets, roles. So all these things we discuss as part of the course. And setup is just a document. Yeah, so all these are the applications we are going to write as part of our course. So I start with zero knowledge inside Docker, and then we will go into the deep, from basic to advanced level. Okay, so these are the things we are going to discuss. So now, any questions? And I forgot to mention, what are the prerequisites you should have to learn this course. You should have Linux commands understanding. You should have some CI/CD release process understanding, not CI/CD, it's like at least manual process, how you are deploying the applications now. And then if you have shell scripting knowledge, that's very, very good. And that's needed also. Yeah, so these skills are enough to learn this. And you no need to have the development knowledge. It's not about developing the application. It's about providing the infrastructure to the developers. So you no need to write any Java applications. You no need to have any knowledge. Just scripting knowledge is good to have, but definitely you should have Linux knowledge.
Siva, what is GitOps? Somebody had asked one question about GitOps.
Yeah.
So could you please explain a little bit about?
Yes. So you are aware of Jenkins.
Yes, a little bit. I know about Jenkins.
So you know the freestyle job, right?
No, not much.
Okay. So whatever you do in the console, suppose after some point of time, if you do some mistake, so can you easily find who did that mistake and can you easily restore that configuration?
So is it something like GitHub? Because no, actually I'm a developer, so I don't know much
Yes.
about the server side. So this is what I want to correlate with. Is it like GitHub?
No. So it's a concept. It's not any technology. It's not a tool. So what I'm saying is, so if you want to launch a server or if you want to some configurations, so we don't prefer to go inside the web console and selecting some options. So you know how to spin up a VM in AWS?
No.
Okay, so something you do the changes in the console, maybe Tomcat console, JBoss console you are aware of, right?
Yes.
So you are selecting some options, clicking some options, and then finally submitting. If something goes wrong, it's very difficult who did that change, and it's very difficult to restore back the configuration. Correct? Maybe it will take 3 to 4 hours time by going through the logs, what's going wrong. But GitOps is nothing but you don't touch the console, you don't touch anything. You write some scripts and you upload those scripts to any source code repository like Git or Bitbucket, GitHub, and from that point of time, the release process will start.
Okay, understood.
Okay, so now what I mean to say is everything as code, not only the development, even your infrastructure, your configurations, all those things you can use code. Why? Because you can easily track. Because you do some changes, you push to the Git repository, there everything is noted, and you have the previous versions also. If the current code is having some problem, you can easily revert back to the previous version. Just like your application, if it has some problem, you can always revert back to the old stage. Just like that, you have a feature in infrastructure also that's called as GitOps. Just touch it in Google, it gives you interesting topics as well. For you can easily understand as you are a developer.
Okay, I got it.
Okay, Anusha is leaving off me. Okay, no problem.
Hello.
Yes, security aspects we will cover. We will not try to run our containers as a root users. Terraform, I will not cover. I will provide you the script because that's a different topic and it's a very big topic. So I can just walk you through the script and what that script will do. It's just to create Kubernetes cluster using Terraform inside Google Cloud. Docker is different. K8 is different. Instead of K8, you can go with Docker Swarm or Mesos also. So yeah, mostly we do our work using command line. So there is some command called kubectl. So using that command, we always interact with Kubernetes master. So you run some scripts like this, and how you will publish this to the by running kubectl and then this file. Then it will start pushing this file to the Kubernetes master. Kubernetes master will understand this script and it will start spinning up the resources.
Hi Shiva.
Yeah, hi.
One question. So just want to know, so you're gonna be teaching not only Kubernetes but Docker, the Jenkins CI/CD pipeline also,
Yes.
or only
Just,
Kubernetes?
yeah, just learning Docker, just learning Kubernetes will not help, right? So in real-time environment, so you always integrate your Kubernetes with CI/CD. And hope you are aware, Jenkins is the mostly preferred CI/CD tool in the market.
Yes.
So as I said, I don't want to touch manually. So whenever I push something to the Git, so that CI/CD pipeline will run, and it pipeline will push the configuration to the Kubernetes master. That's
Shiva,
like
one more query. So, do we need Linux or some kind of this kind of OS to learn Kubernetes or Docker, or Windows is fine?
You mean to start practicing or to understand?
Yeah, to start practicing definitely. So when you start teaching about the codes, right? So we
So
need to deploy it somewhere.
everything is cloud. Everything is within the cloud. You don't need to have any resources in your laptop. You just need one very bare minimum laptop with maybe 4 GB RAM. Yeah, currently everyone is using 4 GB RAM laptop. That is enough. So everything, we don't run anything in local. So we will replicate the almost real-time environment. So we don't run anything in local. Everything we connect to the cloud. So I request all of you to create a Google Cloud account. So that gives you around 20,000, more than 20,000 rupees for free for practicing. So without spending 1 rupee money, you can use it for 1 year if you carefully use it. And
Okay,
you can
Google
learn a
Cloud,
lot
right?
of,
So
yeah,
we can also
Google.
deploy this application on AWS.
Yes, AWS also you can use, but AWS is not much free, so they will charge you. So any end of the day, any cloud is same. Either if you spin up your Kubernetes in Google Cloud or Amazon or Azure, so the concept is same. Just user interface will change. That's it.
Okay, understood, Shiva.
Yeah. Yes, you can install Docker in Windows. Also now Windows 10 OS come up with embedded Linux, and you just need some VMware software, I think. But mostly you don't need to run inside your Windows. So we will create some instances in Google Cloud. We interact with those instances. Like I said, I have given you an example, host-based, right, installations. We install Docker inside that, and we can start communicating with that. And you can run in Windows also. That's not a problem.
Hi Shiva.
Yeah, hi.
Are you covering this Ansible writing playbooks and all, or?
Yes, I will tell how to write playbooks, and I'll explain in simple, like I'll make you comfortable. How can you go and search more and more about Ansible? So for now, as part of this course, I'll cover Ansible and Terraform to spin up the cluster.
Okay.
So Ansible and Terraform, they both are very big topics. I don't want to spend the time on it. Our main
So,
is Kubernetes. Yeah.
so maybe whatever the useful, up to the course, I mean, like Docker and Ansible, that part you will be covering, right?
Yes. So once you write something, right, some application, writing this Ansible playbooks for another application is not a difficult one. Suppose you develop one application on Java application, developing another application is not difficult, right? So same you can.
Yeah. So and also one more question. I mean, can you tell us what is the duration of the course?
So it
Some
takes
details.
30 to 35 hours.
Means how many days?
Hello? Yeah,
Yeah,
it
that
takes
too
30 to
only
60 hours.
in the weekdays, right? And the same time we
Yeah,
joined
same
today,
time like today. Same time like today.
and from Monday to Friday.
Maybe Saturday also, because all of us are in home, right?
Yeah, correct. Yeah, that's all. Okay, thanks.
Shiva, is this for 1 hour or 1.5 hour?
Maybe we can have it 1 hour 15 minutes. 1 hour 15 minutes like that. So I cannot promise every day we may complete it in 1 hour. It may extend based on that context. If we are in middle of something and everybody is interested, right, to complete it, we cannot leave it in middle. So I try to complete it in 1 hour 15 minutes daily. Very few times it may extend. That's it. Okay, so next 3 classes. So it's very important, right? We start discussing about the Docker. Then you will get some understanding more about this technology. But I'm very sure. So this is the mandatory skill in the market after some time, definitely.
And Siva, how much knowledge of Linux is required?
Just understanding the commands, so that's enough. So for example, if I copy something in Windows, I will click Control C and then I'll paste somewhere Control V, right? So in background, Windows also run a command like cp space what is the source path and what is the destination path. So any command in Linux or Windows, so it's just what is the command, what it will do, and what are the options you can provide.
Okay, so the basic commands I need to understand.
Yeah,
right?
basic commands, and even you don't know the command, if we get that command, so you need to understand by reading sometime, maybe 1 or 2 minutes, you can easily understand that what that command is doing.
Okay. Understood.
Yeah, so the technical stack for K8 admin job is nothing but what we have discussed, like Docker, whatever I shown you in this slide. So these are the things you need to mention in your resume. It's good to have. It's like a very good technical stack, as I just noted down here. So you can attempt TKA certification also with this, so because everything we are doing practical.
We will be doing only blueprint deployments, or other deployments also we will do.
Jenkins and Harness. So Jenkins is more than enough, but we can try Harness also.
Okay, so deployment are of multiple types, right?
Multiple types means?
Like one is blue-green deployment, another one is like recursive deployment, and some multiple types
So
of
we can
deployment.
try 2 deployment strategies, blue-green, and then we can go for rolling out deployments. So blue-green is the most popular deployment type out of 6 deployment strategies.
Okay. Yeah, blueprint is like something making multiple servers. If some other server is busy, sorry, it's good, then we can switch the context to other server, right?
Yeah, so you can compare. So maybe maximum companies are using blue-green only. This is the thing you have to compare. So that's a special thing I need to tell you about this one, right? So blue-green is providing more features. Just the disadvantages is, so you have 100 servers. Blue-green will spin up 100 servers, and that will not cost you more because we are using containerization, right? We are not going to buy a new servers. We are going to use the existing servers only. And then rollback, if something goes wrong, rollback duration is almost, see, you can see here 0.
Yes.
That's the main feature we need. So how soon you can roll back your application if something goes wrong?
Yeah. Shadow is one of the more like prominent.
Yes, Shadow is looking more, but it is serving real-time traffic. For example, you have already 10 servers running. You want to go for deployment. What we do in Blue Green is you will spin up another 10 servers and you deploy the application, and inside that, if it is giving correct results, then you switch the route. You switch the real-time traffic to the version B of your means like a set servers. So for example, set of A servers, it has 5, set of B servers. You will spin up another new 5 servers, you deploy the application, you test everything, then you just do some network configuration, switching the route to the version B. But here it is saying it will be serving the real-time traffic also. But it's not good, right? Before testing, you are routing the real-time traffic to your new servers, then that may give some bad results. So that's why blue-green is preferred. So always blue is the production, green is the backup. So you deploy your application in green. If that is behaving as expected, then you will switch the route to the green, and you make this blue as green, green as blue. Just it's like a switch out.
Okay. But as far as I understand, either in Shadow or in Canary, we just provide like 5% or 10% of routing to the server, right? So if it is working fine, then we switch the context to the server B.
Yes, that also we can. So that's like a rolling deployment. So it's first, that's a different strategy.
Because Canary, as far as I understand, because I was studying a little bit about AWS, then I get to know about the Canary that it is like testing of your server. If your server is if you have built a server like server B, and if you want to test it, so you just open 5% of the traffic to the server B.
Yes, yes. You will route maybe your internal users may be available at the time. 1 second. Just be in line for 1 minute. I'll come. Yes, I'm back. Okay, we'll discuss about this deployment strategies. It's just based on the requirement. So we will practice blue green and one more deployment. That's not a problem.
Okay, understood.
So
yeah, so there's a question I can see in the chat. Someone has asked. So which is better, AWS, Azure, or Google Cloud for K8 admin?
Because Kubernetes is from the Google, right? So spinning up Kubernetes resources in EKS and Azure, it may take some time. It's native of Google, so it's always better inside Google Cloud with no issues almost.
Okay.
But that's purely just like they're providing the servers, that's it. So any cloud is fine. Nowadays, all the companies are using almost all the clouds, AWS, Google, and Azure. if you have your projects in AWS, suddenly Google Cloud is coming up with very, very less pricing, at least 30% less than your current cost, then projects are deciding to migrate to the Google Cloud. So now we are writing cloud native applications. We can easily switch between the clouds from on-premise. It's very easy now. Cloud doesn't matter, you can use any cloud. So that you will see. So this is Kubernetes. It's like a cloud native application. So your application behaves same in any cloud. Okay. Any more questions? So tomorrow, so you just forget tomorrow session, you just forget Kubernetes. First, let's get our hands dirty on Docker. Then you get some confidence. Once you understand Docker very well, Kubernetes doesn't matter at all. It's just an orchestrate. That's it. Okay, so if no questions, can you provide this? Okay, that will speak offline. So I can definitely, if you want, I can conduct mock interviews also. So if some candidate is ready for the interview, so first I will interview him, and then I can give some tips to answer some questions, some real-time scenarios, how to address, how to convince other side people, like you have at least 2 years of experience in Kubernetes. So don't feel you are preparing for the interviews, just feel so we are all part of Kubernetes team, and then we started implementing Kubernetes in our company. So that's how you feel when you are getting this training. Certification is necessary. If you have, then suppose if I get 10 people, maybe if I have 2 people with certificates, always they are preferred rather than 8 people, right? But it's most of the time what you first tell in the interviews matters other than you have certification. Once you are confident, you can go for certification. Companies will reimburse you.
Actually, I'm preparing for certification first. This is my priority.
Yeah, so you can always do the certification.
So you also let us prepare for the certification, and you provide some kind of questions, right? Mock questions.
Yes. So we'll mention all the points what are needed for the certification also. So we'll discuss the scenarios also while discussing in the training. What are the topics you are going to get? It's all about writing some hands-on conference you should get. If I tell you before, more than interview, now everybody is preferring giving some assignment to you and complete it. Maybe I will ask you to write a simple, to deploy a simple hello world application in Kubernetes with high availability. So you need to first create the image, you need to store the image somewhere, and then you need to write the pods, replica sets for high availability, auto scaling. So you can easily do it right after if you practice our training.
Yeah.
Okay, yeah, so any more questions? If no questions, we can wind up.
Siva, one
Yeah.
question from my side.
Yes,
You are
yes,
talking about cloud native applications, right?
Yes.
So what microservices we are going to deploy, this is of cloud native nature.
Yeah, cloud native is nothing but the concept, right? So if you develop an application, for example, today your application is in, for example, some PaaS like PCF or AWS or AWS EBS, Elastic Beanstalk, or maybe your application in Google Cloud Kubernetes. Suddenly your Google Cloud at that region, a disaster may happen. So how soon you can deploy the same application into another environment? If you think about VMs,
Yeah. So what I on the high level I understand is this can be achieved uh, from the application side on the cloud. I mean, application is there and the cloud, and your pods are there, and
yes,
you need to build a wrapper in between, kind of an implementation which has some annotations and all stuffs of cloud based stuffs, maybe Spring Cloud, just an example from my side, kind
yes,
of stuffs.
our
And
Docker container itself is a package. So if you run the, suppose if you run your Java code in Windows or Linux, it gives the same results, right? Similarly, our Docker container, which contains the base OS and the libraries and the softwares like Java 8 and your application, so that package will behave same if you deploy it in Windows, Linux, Google Cloud, AWS, anywhere.
yeah, I understand, but just wanted to know more on that part. Like, do we have a Java implementation which supports this cloud native, or we have implementation on the Docker side or Kubernetes side to support this?
No, you should, while developing itself, the cloud native means microservices, that's for sure.
Yeah.
And you should be ready to deploy those microservices as containers.
Okay, so then my question is, are we going to brush this part? Let's say I have enterprise, I mean, Spring Boot knowledge, or I mean, application knowledge, where
Yes.
we are going to put the annotations or the implementations, and convert that application to cloud native application. This part is also covered here.
No, that's purely a development part. So you can assume, right? So while you're writing the annotations, for example, if you're referring some properties, other than referring from application properties, you can refer some Vault, HashiCorp vaults, or Spring Cloud config servers.
Yeah.
So that part you have to prepare as that's a development part.
Okay. Yeah.
Okay, ours is purely like providing necessary infrastructure to the developer. So as you are developer with development as well as infra, that gives you more preference in the market.
At least our application which we are going to use for deployment. Let's say we have some sample microservices.
Yes, that's a microservice application. Yeah.
Okay, so that is cloud native. Already it is developed and it is cloud native.
Yes, already it's a microservice. Then we are going to convert it as cloud native. But,
okay, so and we will switch over. Let's say we can deploy that to Google Cloud, or we will deploy that to Kubernetes. Something
so
like that.
anything is good. Okay. So it's just a image container, right? So if you run that container in Google Cloud, anywhere it's fine. Anywhere it's very easy. You're not going to do more changes, maximum very less changes. That's it.
Okay.
Okay. So don't worry. So we will discuss that. We'll get more understanding. So, scripting language needed for K8 automation. So shell scripting is good. Scripting, it's not don't think it is a programming. Programming is different, scripting is different. Scripting is just instead of running 10 commands one by one, you always place those commands in a file and you will run the file. That's scripting, that's it. So one if condition, maybe one for loop, maybe one while loop. That's all scripting. Other than that, nothing. So programming is different, connecting to the databases, doing some complex business logics, authorizations, authentications. So a lot of things to handle. That's so everybody, almost everybody in software may feel scripting and programming as same. But scripting is very, very easy. Just placing all your commands one by one. Maybe sometimes the condition for loop, while loop, for that's it. So I will show you one scripting, maybe just to remove the fear of scripting. A lot of people will be asking scripting, all those things. Okay.
Hello, Shiva.
Yeah.
This is Wahid. I have one doubt. Docker itself has a container orchestration engine as this Docker Swarm. Then why should
Yes.
we go for Kubernetes?
So that native Docker Swarm is not so much scalable. After some point of time, you feel it's very difficult to manage the swarm.
That means technically.
So it will not give you more features like Kubernetes objects, right? It is giving you replica sets and stateful sets, daemon sets, deployments. So those kind of all features are not available in Docker Swarm. It's just like passing some commands. Docker Swarm really cannot maintain all those features that you have to write it yourself. For example, like suppose you have some libraries right everywhere. So if I want you to generate one random number, you can use something like map.random in Java. That line. If you want to write it yourself, you have to write a lot of commands, right?
Now we can write a random command.
And just like you can think of using libraries, not reinventing the wheel. That's it. I want to say. So just we will write the. I will give you one sample shell script also. That's not a problem. You can easily understand. Just I'm placing the commands. So any programming or any scripting which will contain just one if condition, for loop, while loop, and functions. Only these concepts. So later it's just like how you think about the application. The complexity is not in the programming language or technology. So the complexity lies the way you think. You don't ever think the syntax, all those things, just think the flow. Then 10% is the development part or implementation part. 90% is like design part. Okay. I think that's getting more. If no questions, so final call for questions. Okay, so I think we can wind up. I'll share this recording tomorrow same time. So we'll start using Docker. Okay. So thank you so much.
Siva, one thing. So you will send this video tomorrow or today?
Yeah, today I will send it.
Okay. So on Gmail?
Yeah, I'll send it. I'll upload it to YouTube and I'll send the link to you.
Okay, I got it.
Okay. Yeah. Thank you so much.
Yeah, thank you.
See you. Have a nice day. See you tomorrow.
Thank you, Shiva.
Thank you, Shiva.